Always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing. Never give up, never slow, till I finally prove it.
Objective: write numbers in scientific notation and vice versa. Good morning and welcome to my class. Test, multiple choice, write the letter of the correct answer on a sheet of paper. Number 1. It is a way of writing very large or very small number. Letter A, scientific notation. Letter B, integers. Letter C, rational number. Letter D, real number. Number 2. What is 500 in scientific notation? Letter A, 5 times 10 raised to 0. Letter B, 5 times 10 raised to the first power. Letter C, 5 times 10 raised to the second power. And letter D, 5 times 10 cubed. The next number, what is 353,000 in scientific notation? Letter A, 3.53 times 10 squared. Letter B, 3.53 times 10 cubed. Letter C, 3.53 times 10 raised to the fourth power. Letter D, 3.53 times 10 raised to the fifth power. Number 4, how do we write 353 hundred thousands in scientific notation? Letter A, 3.53 times 10 raised to negative 2. Letter B, 3.53 times 10 raised to negative 3. Letter C, 3.53 times 10 raised to negative 4. Letter D, 3.53 times 10 raised to negative 5. Last number, number 5. How do we write 353 10 millions in scientific notation? Letter A, 3.53 times 10 raised to negative 2. 3.53 times 10 raised to negative 3. Letter C, 3.53 times 10 raised to negative 4. Letter B, 3.53 times 10 raised to negative 5. Following answers. For number 1, letter A. Number 2, letter C. Number 3, letter D. Number 4, letter B. And the last number, letter D. A is 1, B is 2, C is 3, up to the last letters. We need to write the letter that corresponds to the given number. For example, we have number 1. Number 1 is letter A. For number 3, we have letter C. I want you to complete the words in the given. We have the answer. The answer is scientific notation. Did you get the correct answer? Very good. Scientific notation is our lesson for today. Write the following numbers as power of 10. 200. 200 is 2 times 10 squared. How about 9,000? 9,000 is 9 times 10 cubed. Write the following numbers as power of 10. The first number is 60,000. The next number is 70 million. I am giving you time to answer the problem. Now ready to answer the problem. Number 1 is 60,000. That is 6 times 10 raised to the 4th power. We have number 2. Number 2 is 70 million. That is 7 times 10 raised to the 7th power. Did you get the correct answer? Very good. Who created scientific notation? Archimedes created scientific notation. Scientific notation. Scientific notation is a way of writing very large or very small numbers. Scientific notation. A number is written in scientific notation when a number between 1 and 10 is multiplied with the power of 10. Example, 650 million can be written in scientific notation as, we need to place a decimal point after the first non-zero digit. The first non-zero digit is 6, so we'll be placing the decimal point between 6 and 5. Then we count the number of digits to the right. 1, 2, 3, 4, 5, 6, 7, 8. So our answer is 6.5 times 10 raised to the 8th power. Write the following numbers in scientific notation. The given is 123. Look at the first non-zero digit. The first non-zero digit is 1. So we need to place the decimal point between 1 and 2 and count the number of digits to the right. 1, 2. So the answer is 1.23 times 10 squared. We are in the next number, 1,230. The first non-zero digit is 1, so we place a decimal point between 1 and 2 and count the number of digits to the right. 1, 2, 3. So the answer is 1.23 times 10 cubed. We are in the third number, 12,300. The first non-zero digit is 1. Then we have 1, 2, 3, 4. That is 1.23 times 10 raised to the 4th power. We are in the fourth number, 123,000. The first non-zero digit is 1, so count the number of digits to the right. 1, 2, 3, 4, 5. That is 1.23 times 10 raised to the 5th power. And the last number, 1,230,000. The first non-zero digit is 1. Count the digit to the right. 1, 2, 3, 4, 5, 6. So that is 1.23 times 10 raised to the 6. We need to write the following numbers in scientific notation. 1,280. The decimal point is between 1 and 2 and count the number of digits to the right. So we have 1, 2, 3. The answer is 1.28 times 10 cubed. We have 500,000. So we have the decimal point here. That is 5 times 10. 1, 2, 3, 4, 5. 5 times 10 raised to the 5th power. We are in the next number, 68,720,000. That is 6.872 times 10 raised to the 7th power. And the last, we have the given. So this is 9.2 times 10, 3, 6, 9, 11. 9.2 times 10 raised to the 11th power. We need to write the following numbers in scientific notation. Notice that all the numbers and the given are less than 1. If the numbers are less than 1, we have a negative exponent. What is the first non-zero digit? The first non-zero digit is 5, so we'll be placing the decimal point between 5 and 8, and we count the number of digits to the left. So we have 1, so the answer is 5.87 times 10 raised to negative 1. We are in the next number, 25,000. So in 25,000, the first non-zero digit is 2. So we'll be placing the decimal point between 2 and 5. So and count the number of digits to the left. 1, 2. So the answer is 2.5 times 10 raised to negative 2. are in the third number. So we have 56 10,000s. So the first non-zero digit is 5. So we'll place a decimal point between 5 and 6. Then after that, we count the number of digits to the left. 1, 2, 3. So that is 5.6 times 10 raised to negative 3. Then we are in the next number, 258 millions. And the given number, where the first non-zero digit is 2, then count the number of digits to the left, 1, 2, 3, 4. That is 2.58 times 10 raised to negative 4. And in the last number, we have this one. The first non-zero digit is 2, so we have 2.54. Then count the number of digits to the left, 1, 2, 3, 4, 5, 6, 7, 8. So we have 2.54 times 10 raised to negative 8. Going to answer the activity, write the following numbers in scientific notation. For number 1, what is the answer? The answer is 7.8 times 10 raised to negative 3. How about the next number? That is 9.2 times 10 raised to negative 1. For the last number, we have 2.5 times 10 raised to negative 5. Write the following numbers in decimal notation. 6 times 10 raised to 0, the answer is 16. 2.57 times 10 raised to the 5th, we have already 2 here. We need 3 zeros. 257,000. So we have 5.4 times 10 raised to the 7. We have already 1. We need 6 zeros. So we have 54 million. Next, 1.65 times 10 raised to negative 1. Move the decimal point to the left. We have the 165,000s. 1.65 times 10 raised to negative 2. Move the decimal point 2 places to the left. So we have 165 10,000s. For the last number, 1.65 times 10 raised to negative 3. We move the decimal point 3 places to the left. So we have 165 100,000s. Answer the activity for number 1, 417. Number 2, 8,000. Number 3, 42,313. Number 4, 61,000. And the last number, we have 153 millions. How do we write numbers in scientific notation and vice versa? To convert any number into scientific notation, you write the non-zero digits, placing a decimal after the first non-zero digit. Write the digits as a decimal number between 1 and 10. Count the number of places and that you move the decimal point. Multiply the decimal number by 10 raised to a power of n. So if the movement is to the right, the exponent is positive. If the movement is to the left, the exponent is negative. Change the number in scientific notation with a positive power of 10 to standard form. Move the decimal point to the right. The exponent tells you the number of places to move the decimal point. Remember to add zeros as placeholder when necessary. To change a number written in scientific notation with a negative power of 10 to standard form, move the decimal point to the left. The exponent tells you the number of places to move the decimal point. Remember to add zeros as placeholder when necessary. So we have the real-life situation in scientific notation. We have the density of oxygen can be written in scientific notation, and the diameter of the grain of sand can also be written in scientific notation. Real real-life situation in scientific notation. The distance from Earth to Sun is 150 billion meters. Right in scientific notation. That is 1.5 times 10 raised to the 11th power. Estimated number of cells in a human body, 100 trillion cells. Right in scientific notation, that is 1 times 10 raised to the 14th power. And that is science integration. We need to write the following numbers in scientific notation. We have problem number 1 to problem number 10. I am giving you time to answer the following problem. Now ready to write the following numbers in scientific notation. Number 1. Number 1 is 0.75 times 10 raised to the power. Number 2. 6.3 times 10 raised to negative 4. Number 3. 9 times 10 cubed. Number 4. 8 times 10 squared. Number 5, 3.8 times 10 raised to negative 4. Number 6, 8.65 times 10 raised to the 4th power. Number 7, 4 times 10 raised to the 6. Number 8, 5.75 times 10 raised to 0 exponent. Number 9, 2.6 times 10 raised to negative 5, and the last number, 4.5 times 10 raised to the 1st power. We need to write the following numbers in decimal notation. We have problem number 1 to problem number 10. I am giving you time to answer the following problems. Answer the problem. 2.3 times 10 raised to the 7th power. We have already 1 here. We need another 6 zeros. Then we have 6.9 times 10 raised to negative 3. We have already 1. We have 2 zeros before the decimal. We have 3.1 times 10 squared. We have 1, 2. So we have 310. 2.86 times 10 raised to negative 6. We have already 1. We have 5 0 before. Then 7.11 times 10 raised to the 1st power is 71.1. 6.25 times 10 raised to the 5th. We have already 2. We have additional 3 zeros. 7.51 times 10 raised to negative 9. We have already 1. We need 8 zeros. And we have the last number, 5.85 times 10 raised to 0. This is still 5.85. So we have negative 2 as our exponent. We have already 1. We have 1 0. Alright. And for the last number, 5.19 times 10 raised to 7. We have already 2, and we have 5 zeros. We have our post test, multiple choice. Write the letter of the correct answer on a sheet of paper. Number 1. It is a way of writing very large or very small number. Letter A, integers. Letter B, scientific notation. Letter C, rational numbers. Letter D, real numbers. Number 2. What is 5,000 in scientific notation? Letter A, 5 times 10 raised to 0. Letter B, 5 times 10 raised to the first power. Letter C, 5 times 10 squared. Letter D, 5 times 10 cubed. Number 3. What is 35,300 in scientific notation? Letter A, 3.53 times 10 squared. Letter B, 3.53 times 10 cubed. Letter C, 3.53 times 10 raised to the fourth. Letter D, 3.53 times 10 raised to the fifth power. Next number, number 4. How do we write 353 10,000s in scientific notation? 3.53 times 10 raised to negative 2. 3.53 times 10 raised to negative 3. 3.53 times 10 raised to negative 4. Or 3.53 times 10 raised to negative 5. Last number, how do we write 353 in scientific notation? 3.53 times 10 raised to negative 2, 3.53 times 10 raised to negative 3, 3.53 times 10 raised to negative 4, or 3.53 times 10 raised to negative 5. Now answer our post test. Number 1, letter B. Number 2, letter D. Number 3, letter C. Number 4, letter A. And the last number, letter B. To speak about notation as the only way that you can guarantee structure of course is already very suspect. By Ivan Parker. Thank you for watching.